Community, welcome to the PX4 Developer Summit. I want to thank everyone for tuning in. We're incredibly excited to have more than 1,600 of you here. Before we get started though, I want to thank the team of more than 70 who are making this event possible. Staff, volunteers, speakers, sponsors, partners, and last but not least, my family. There's no denying that COVID-19 has dramatically impacted the lives of all of us. Remember, one small gesture can save lives. Please follow your local authority guidelines, take care, and help others. During the following days, we're going to take a deep dive into the depths of the PX4 community. It's been a year since we last met in Zurich, and the community has been really hard at work. I want to start the day off by announcing that Maxwell Innovations today joined Dronecode as a silver member. Thank you, Maxwell Innovations. I'm going to be hosting the main track of the conference. I'll be joined by community speakers selected by the content committee. You will be able to ask questions to speakers at any time during your presentation. Our team of community volunteers will collect questions. The pre-recorded talks can be found on the PX4 YouTube channel. Make sure you don't miss the speakers on the chat room while the video premieres though. Feel free to ask as many questions as you want. It's a unique opportunity. Make sure you make the most out of it. Make sure you follow PX4 on social media for special announcements. Let's get started with our first speaker. Dr. Lorenz Meier is the co-founder of Avoidance, chairman of Dronecode. He will be presenting Setting the Standards in the Drone Industry for a Decade. Lorenz is calling in from Zurich. Please stand by while I connect you. Don't move. Be right back.
I really hope that we can meet next year in person. I really appreciated meeting everybody last year in Zurich, in summer, having time off, having time out as well, next to all the intense presentations. Now, I do hope that the one benefit we're getting this year is that we have a lot of more attendees. We have more than 1,600 people registered. And without long introduction, I would like to show some of the highlights that we have achieved as a developer community over the last year. So we really planned for this event to have 400 people. Now we have a lot more registered. I am expecting that people will dial individually into particular sessions. So I'm not expecting everybody to be here for the opening keynote. And a quick introduction of myself. Ramon has already introduced me. I have founded a number of open source projects back as student over 10 years ago, 12 years ago, the first one. And these are forming together the PX4 ecosystem. And by now, I'm really the chief cheerleader of that ecosystem, but we have a lot more developers that are pushing this forward, in particularly, of course, Daniel Agar, who is taking the technical lead. Now, thanks to the fact that we had to go virtual, this is a truly global event. We're really stoked how many people are dialing in from literally almost every continent. I don't know if we have Antarctica, but other than that, I think we're pretty covered. And so I hope that this will spur further discussions, more contributions from across the world. With that, big thank you to all of our contributors. We have hundreds of contributors across all the different projects. This goes way beyond PX4 firmware. We have things like MAV SDK, we have the simulator, and all of those have lots and growing of contributors. So thank you for doing that. If you haven't contributed yet, there is a session in the program. Please look it up, how to contribute. Please approach us on Slack. If you're not quite sure what contribution means, it typically means taking a change, an improvement, or maybe just a bug fix, and sending a pull request on GitHub onto one of our repositories. So please keep doing that. And I'm pretty sure we didn't capture all the profile pictures of every single contributor, but these hopefully stand in for all of you who have contributed code, have contributed documentation, have contributed flight testing. And so big thank you. This community, this open source project really relies on you, and we would be nowhere without your continued effort. Thank you. So for those of you who haven't been with us for years, maybe this quick recap of our history is an helpful introduction. So I'll usually do this quickly every year. Pixhawk really started as a student team at ETH Zurich in 2008. We wanted to do autonomous flight using computer vision on drones. Back then, you couldn't buy autopilots. So we ended up building our own and then making the hardware and software available as open source and open hardware. And this is really what started this ecosystem, because other people came in, piled in, helped to develop that. Now, 12 years later, we really start to shape up industry standards that are actually adopted beyond the coverage of just core open source as an open source project. But even companies like Skydio or Parrot are implementing, for example, our ground station communication standard in their latest commercial models. With that, feel free to look that up. There's also a history on our website. We've come a long way. And I believe that the adoption of open source software will grow further, because as these machines, as drones, as autonomous systems become more and more complex, you really need a very deep software stack. And PX4 itself is, by now, I would call it more like an ecosystem, like Linux is an ecosystem. It's not just anymore the core PX4 kernel. And so that growth is forcing more and more individuals, and in particular also companies, to adopt open source software, because that's the only way how they can keep moving. Otherwise, they would need hundreds of developers in every single company to achieve that, and that's just financially impossible. So things look great, and I hope that a lot of the companies that might still try to do things themselves or everything themselves will come around over the next 1 or 2 years to adopt PX4, because at the end of the day, that's really the only way to sustain software on drones going forward. Now, the other question that often comes up is like, okay, but how do I really build my product? How can I use the same code as everybody else and then not get kind of just turned into a pure hardware company and have no profit, have no differentiation? Now, the way to do that, you can use open source software, is you have your product and you build that product at a particular point in time, maybe 2017, 18, whatever it is. And typically that involves the industrial design, that involves the whole airframe, that involves the whole system integration. Now, back then, you didn't need to have obstacle avoidance or computer vision or safe landing planning or anything like that. Today, customers kind of expect that. So the cool thing is, if you build that on top of an open source ecosystem, you can bring your product along. So instead of just having now to re-engineer all of that, you can just put it on top of more technology that becomes available to you over time. So this is how you sustain your product on open source. And I'm expecting that most of you on this call will understand this, but maybe you can pick this up as a way to pitch it to your management, why you should and can work more intensely with other developers. Now, let's look at this year, 2020. What is PX4? It is still very much what it was last year, which is an open source project that is used in 3 core industries: consumer, commercial, which includes government usage, and what we call industrial. Industrial is a bit emerging. So consumer, we all know consumer drones. There's, of course, one elephant in the room with one very, very big company that has a lot of market share, but there are still a lot of companies that use PX4. Most of them don't talk about it. In commercial, people are much more proudly talking about PX4 because it is about interoperability standards. Their customers usually want to know what's inside. They want to know, is that a software I can trust? Is it transparent? And so that's where we have right now a lot of traction, and I will have quite a few examples of that in the rest of the presentation. Now, an upcoming industry, and actually the biggest difference between last year and this year is in that sector, are industrial applications. And to me personally, the main difference between commercial and industrial is commercial is kind of a better consumer drone. It's a bit bigger, it's a bit more reliable. It is built for workflows rather than personal joy. Now, industrial drones are built for continuous heavy operations. They're waterproofed. They are fulfilling certain safety regulations and standards. They also are often a lot bigger. And that includes cargo drones, flying cars, urban air mobility. I think PX4 right now is not something that's built for urban air mobility, but as we clock up more and more flight hours, who knows where we will be running in 3 or 5 or 10 years. And we see that as a big trend across the whole industry. Governments and corporates are going more and more open source. And that's not just Microsoft with GitHub and Visual Studio Code. It really is also Microsoft partnering with the PX4 community and deepening that relationship. We have a great presentation from Microsoft on simulation, on their integration with AirSim. Check it out in the program. And then also GE Aviation has partnered up with Auterion to use PX4 in their safety critical autopilot. Also great presentation on that topic by the GE team. Check it out in the program. Now, there's one interesting thing that I'm lately spending more time on explaining, and that is the difference between PX4 as a technology and PX4 as an ecosystem. And it's a bit the same thing as with the Linux kernel and the Linux ecosystem. The PX4 ecosystem is really with PX4 at the core, which defines the core interfaces, the core technology. And then you have a number of open source projects like Ground Control and Mav SDK around it, which are also technology fundamentally. But now we start to have more and more industry standards. And these industry standards are standards that we are implementing certain software functionalities, certain interfaces, like Pixhawk, like MAVLink. They have been around before, but now we're becoming more clear about the boundaries, about the functions. And there's the industry association. And there we did one clarification recently. Dronecode has always been confused with PX4, like I'm running Dronecode, or what is Dronecode, or is Dronecode a company? No, it's a Dronecode foundation, and that's how we will start to consistently call it going forward. It always has been a nonprofit in support of open source, a collaborative project by the Linux Foundation, but we'll just call it Dronecode Foundation, and it's really clear. So that's the industry association behind the PX4 ecosystem, which is helping to organize this event, which is helping to organize our YouTube channel, social media, which is contributing the salaries of our program manager, Ramon, and of Ginger, who is working with our community. And then, of course, also really important, there are third-party projects, and this isn't meant as like dismissive third party, this is meant as very respectfully. There are integral projects that we really need to function, like ROS. And we'd love to have a really close relationship. We have one of the ROS founders, Tali, presenting here as well. And our goal with them is to just work really closely together and maybe converge on an ecosystem level the same way as, I don't know, Docker and Linux work really well together. So also really important. Now, one of the urban myths about Linux is that it's developed by hackers sitting in the basement of their moms, which is not quite true. Linux is, for the past probably 15, 20 years, developed by professionals working at large corporations, at IBM, at Red Hat, at Intel. And the same is very much true for PX4. Initially, it was driven by researchers, enthusiasts, hobbyists, but that has changed over the years relatively rapidly. So today, over 85% of contributions are coming from enterprises. And those are typically not IBM's, but Microsoft, for example. But it's really companies using the software. And so we're continuously working with them. And one of the things I really want to make really clear as somebody who is both affiliated with PX4 and Auterion, really today it's all about PX4, and we're just showing the individual companies who are contributing, including Auterion, which has a big share here, because we want to make that transparent, also in a way to thank you, those companies, for their continued contributions. In terms of countries, also no big surprise there. As Auterion has a lot of R&D in Switzerland, we have a lot of contributions from Switzerland, but we also have contributors, developers in the US, and a lot of other companies who are US-based. So you see quite interesting pattern with Switzerland, US, Australia, Portugal, New Zealand, not quite expected. And we, of course, hope that other nations will pick up here. And so in particular, if you're from around the world, if you're in Asia, make sure to see what you can contribute going forward so those bars change a bit. In terms of firmware contributions, we've again split that up between individuals who work as consultants and corporations. Those are the top 6, or rather top 5, plus the accumulated contributions. You can see again, Auterion is doing a lot as a company. That makes sense, given I started on my open source mission 12 years ago, and the company has become part of that. Q Ground Control, we see that Don is super active. Congratulations if you're watching, or if you're watching a recording of this. This ecosystem really benefits from you, and great work on Q Ground Control. And then again, simulator, avoidance, you can see where the individual efforts are really focused. MAV SDK, which is our SDK, our user space API, and really, really important going forward for the further adoption of PX4, because just working on the core flight controls is way too hard for many developers. Documentation, again, something that we're heavy. So now we know who built PX4 over the past year. Now let's look at who is using PX4. That's hopefully long-term the same, but right now it isn't always. So we have leading products and developer platforms that are being built. I'm not going to read all of them. Just have a look at the logos, have a look at the systems. It is awesome to see that diversity. We have airframes that weigh hundreds of kilograms or hundreds of pounds. We have airframes that are a pound. Really reflects also the technical capability of the software stack supporting all of these applications. I want to show a couple highlights. This is probably the most crazy example that I have. So let me quickly just play the video. And it's a quite surprising use case, something I totally would not have anticipated, that somebody would actually go ahead and fly a VTOL with PX4 as a person. That's pretty crazy and inspiring. Awesome. So I don't want to steal the thunder of the person who did this. So this is an old video on purpose. They're much cooler, much newer videos. So if you're interested in that, check out the talk of Julian tomorrow. Make sure to dial in. There's the time in Pacific Daylight Time. You can also find it in a program. Really, really mind-boggling, very experimental. Now, a little less scary, but still big, is this cargo drone by Valenzi, also running PX4. This is a public safety firefighter drone by Impossible Aerospace, also running PX4. This here is a cargo drone that is also PX4 based, has made the news recently. This is a government drone, also by Vantage Robotics, also brand new, pushing into the market, running PX4. This is another cargo effort for medical cargo by Avi. Really awesome to see the diversity. As you can see here, most of you will have seen the unique products that run PX4. Then we have a waterproofed VTOL by Quantum Systems. You can even see the custom pitot tube, heated and everything. So really cool to see that industrialization that PX4 is on right now. We have the FreeFly Alta, and this is the Alta X. Really, really big drone, being able to lift really heavy camera gear, used in Hollywood. Really cool to see what they're doing and the flight performance they're getting out of it. And then this is Elroy Air with this in the background is not a toy aircraft. It's a real Cessna with a huge cargo drone based on PX4. Really cool. And then this is a recent startup from ETH Zurich, also running PX4 on their overactuated. Usually multi-copters are underactuated. This one is overactuated inspection drone. Really cool. And then, of course, a company you will have seen before, one that is very close to where I am right now, Wingtrum, with a super cool tail sitter that is based on PX4 as well. So huge variety in weight, in size, in actuation, but all running the same flight control core. With that, let's look at what will carry this open source project into more applications going forward, and those are new partnerships. So Microsoft is not a new partner from last year, but they have renewed their push for integration. We're working with them on AirSim. Super cool. Check out their newest blog post on it. We've recently announced a partnership with ARM/Linaro/96 boards, which is their hardware standard for ARM boards. We're going to do a common standard together that's bringing the compute board standard and our FMU standard, and is going to put that together into a smart autopilot, similar to, for example, the products from Modal or from Auterion Skynote that you've seen recently. So let's quickly talk about a couple more developer-focused topics. Developer workflows. So we're doubling down on testing, and we have two awesome talks. Others will touch that topic as well, around improving testing, including having fault injection in more places in the system. So super important for the further hardening of PX4. And we're also going to have a restarted and increased flight testing powered by the Dronecode Foundation for PX4. Board support and hardware testing. We have clarified how we do board support in this project. So there are new 3 categories: officially supported boards. Those come with the Pixar Standard, manufacturer supported, and experimental. You can read that up. It's online. And we're adding more and more of these hardware targets to the test rig. This is work that Daniel is doing, maintaining, pushing. Big thanks to you, Daniel. This is really important to spot regressions early as we move very fast with the code base. Good. User space APIs, ROS2 support. There are 2 cool talks. Please check them out. We are integrating more and more deeply with ROS. They're coming the embedded way. We come with our publish subscribe framework their way. Really great collaboration for the last couple of years already. And I think it's now ready for prime time, also with us having finally Ethernet on the flight controller. MAV SDK, you already have heard about it. It's the SDK for our ecosystem. Check it out on MAVSDK.io if you're not familiar with it yet. Not going to spend too much time on it. It's a simple way to interface to PX4, and that should do it in terms of description. In terms of safety and certification, lots of talks from Chris Anderson, from James Howard, and from Gokul Krishna Srivasan on various aspects of safety and certification. BVLOS, which is one of the key drivers behind wanting to do certification. So please check out those. With FMU V5X, we've really laid the foundations on hardware standards for that. And now a number of companies, GE Aviation, NXP, Auterion, are all pushing towards that within the open source project. And we're going to try to bring ISO 26262 road vehicle certified parts and technologies and approaches into the drone space, which is a lot more lightweight than aviation certification, but still has a very, very high pedigree and is accepted as being really reliable. I will quickly dash through the Pixhawk standard so we have enough time for the Q&A. So Pixhawk standards, what is that? Like, you know the Pixhawk Autopilot, which is the initial hardware that I did with collaborators back in the day, 2013, and which is named after the student team at ETH, which started in 2008. Now, it's becoming a new life again, this time as standard, because really what Pixar created with being open hardware is creating a hardware standard because people took that design, engineered around it, and so we essentially created a whole hardware set that is why a lot of drone software stacks, drone hardware actually work together, because there was this pseudo standard. Now that the drone industry is getting more regulated, more professional, we're actually turning this into true standard body like Bluetooth or USB. So think of Pixhawk going forward essentially as a Bluetooth for drones. Poor comparison, but it kind of works. So the goal is to specify all the key components and interfaces correctly so that anyone can build to that spec, and we can enable people to have flight controllers that can be mounted properly into drones with zero compatibility issues. We can enable folks to have really easy to use gimbals that can be just snapped on. And the hope is to really create the same plug and play experience that Bluetooth or USB offer to end users. So it's not just about technical, safety norms and anything. The goal is interoperability with that. And the driving factor from a software perspective, our MAVLink, our PX4, but really the standard is standalone. So if you had a different software stack or proprietary implementation, you can still do that. And that allows you, for example, to create a custom payload that is completely your product to interface to that standard. And so it will work with all those PX4 driven vehicles. Check it out on pixhawk.org. I will do a quick high-level overview now, though. So one of the core pieces is the Autopilot Bus. We've seen that many different companies had many different autopilots. For me, in Autopilot, having designed quite a few is actually not too complicated. It's a microcontroller connected to 3 sensors, a bit of power management, and that's about it. And the problems we have seen supporting these different boards and regressions and power supply issues and whatnot were horrendous compared to the inherent hardware complexity. So the pattern over the last 3 to 5 years, ever since we had more and more variants based on this old Pixhawk design and people didn't just re-implement the very core design, we spent a lot of time on this. So the solution to that is to standardize this much more closely so that we can guarantee that if you implement to the standard and you run PX4 on it, it'll work. It'll work every time. You will not have weird power management, power on, power sequencing issues like we have seen them in the past. That's what this is about. So Pixhawk Autopilot Bus is specifying a footprint for autopilots. And the matching standard for payloads for gimbals is the payload interface standard, Pixhawk Payload Bus. And that is essentially the mechanical connector, how you connect, it's a dovetail design, how you connect the gimbal to the body of the drone. It is the software, which is specified as MAVLink, camera and gimbal payload protocol. Electricals, we are supporting USB and Ethernet. And with that together, you can really build a completely standalone gimbal that is not related to any particular drone that will work on a number of vendor systems. And the first company going to market with that standard is FreeFly, based on what I'm seeing. And I'm really excited about that because this industry needs that. There's way too much fragmentation, and all this system integration engineering work is cost for a lot of people in this audience that doesn't add any value, doesn't really further your business, and is also sometimes a reason to not use open source, because as long as you have vendors that are vertically integrated, like DJI, and it's just easy and it just works, and you have a lineup of payloads, you're going to go with that vendor, even if the drone isn't exactly what you need, because you just have better choice taking the picture, which is what really most people care about. And so as you approach this, think again about it if you really needed your vertically integrated special solution, or if you could just go with something that is a bit more standardized, gives your customers more choice, and maybe that's driving, in the end, a lot more business than going after the last bit of specialization. Now, for the specific autopilot, to ensure that we can really run the software successfully, we also need to specify how exactly that autopilot is built internally, not just a connector. That's what these FMU, for Flight Management Unit, V5X, V6X documents and standards stand for. The X at the end is actually indicating the industrial version, so that's the hardened design without X. It's the more developer enthusiast community version. We're targeting roughly 1 version per year. We're on track with that with V5X and V6X. And the cool thing is those 2 designs are interchangeable on the Pixhawk Autopilot Bus. Good. Another important problem, interfacing motors, interfacing ESCs, interfacing servos, and other actuators. So that is something that we're attacking with a new CAN-based interface standard. Think of it as Wi-Fi for drones, of course, not wireless, but it's a high-level spec that includes messaging, includes authentication, includes deployment and software upgrades. So it's a lot more than just a transport layer, and that's why it will sit on top of UAV CAN V1. It's not on the same thing, it's not competing, it's standardizing a message set and state machine on top of a UAV CAN V1 transport. And check out the call from, the talk from Peter, and of course from Pebble, who is also giving us an update on UAV CAN. Good. If you're interested in standards, there's a panel on that next week, tomorrow. So check that out if you want to ask more questions, follow the discussion there. Looking forward to that. Then we're almost at the end of the presentation. There's also an update on how we do releases and roadmap. So in terms of releases, Daniel and I talked about being kind of really stuck in this release stabilization process for weeks, because people come in with feedback, but it takes quite a bit of time to test. And then because the releases are really major steps, major performance wins, but also API changes and kind of hard to digest, we want to make it simpler and easier to stay closer to the current version in upstream. So there will be more frequent releases with gradual, gentle changes. That makes releases more predictable and easier to scope, because we're not having this sort of big step. And that should shorten the cycle between downstream adoption and feedback from companies using it. That will also mean, however, that you will have these small increments all the time. And so if you need something super stable, you need to have your own strategy to stabilize that, also API stabilize that if you want to stay on an old release, which might have been easier with the only 2 releases per year up until now. We believe this will tremendously accelerate our development. It will allow us to bring improvements in faster, and we think that's the right thing for the upstream project. For individual products, we believe that that's a responsibility of each company to create those stable releases for them if they want to freeze things, on a longer time frame than that. Good. Then one last slide. One thing we really don't want to do is to commit too specifically on goals. This is a meritocracy, so it's contributions done by individuals, done by companies, based on best effort, based on when and if they have bandwidth available. But this is roughly what we know our developer community is going to work through the remainder of the year. We're changing the way that the EKF framework is derived to Python to make it more approachable. That's something that Roman initiated, and Paul is now on that as well. So that's really cool. That hopefully opens up more contributions into our state estimation framework. We're working on multi-EKF support that is related to some of the industrial applications and industrial drones. Much more component level testing. Again, check out the talk from Julian about fault injection. We have a new way to allocate control signals to multicopters and VTOLs, which will allow us to develop the flight control architecture in a much more scalable fashion. And then CAN is the other main part, plus quite a bit of hardening, cleanup, structure, like in the commander and navigator, hardware in the loop testing, all those things. There are probably a dozen things I haven't mentioned here. There's a lot of work on computer vision, a lot of work on autonomy, but that is sort of in the wider ecosystem, and these contributions will come in as they're ready. Cool. So that was really what I wanted to get across. Now I'm looking forward to check out your questions in real time. They're appearing on a screen in front of me. First question, how do you see the PX4 platform in the upcoming years? So I think I mostly talked to that, but just let me recap. We expect it to continue to have all the properties for consumer drones, also for recreational use. We plan to invest into auto-tuning, so it's more approachable, in particular also to software developers who might not know how to tune a drone. So the goal is to keep that foundation solid, make it even more approachable. But then a lot of effort is going into commercial and industrial applications. So it's about all the upcoming reliability requirements, all the upcoming regulations, and There we will invest a lot of energy to make sure that PX4 continues to be the best base for a commercial drone product. Second question, is PX4 all about the software side? I would say the PX4 ecosystem is not, as I've shown you with Pixhawk hardware standards. PX4 as sort of a project, yes, it's very focused on software, and that makes sense. But you can see that in the whole ecosystem that we're supporting with Dronecode, it's very holistic, it's full stack. How can interested students get involved with the PX4 community? I think the best way is to join Slack. Our Slack channel, it's slack.px4.io. You can get yourself an invite there. And our forum, which is discuss.px4.io. Question, new company in the drone industry, how can we get started? Well, that's a difficult question because it's so open-ended. It could mean anything. Do you need to find customers? Do you wonder how you can work with PX4? Probably just send me a private Slack message and we can figure it out. Does PX4 have any plan to expand its market to other nations? That's an interesting question. So what I'm taking away from that is that you kind of think or assume PX4 is like a vendor. It's not. It's an open source project. It's in the internet, so it's in any nation available. And we're not expanding, we're not pushing, we're getting pulled in different adoptions because people just download the source code, get successful with it, contribute back to it. So the answer is we get in many different nations all the time because people are successfully using it. What about certification? Are we working with FAA? Yes, we're working with pretty much any regulatory and standardization body under the sun. We're working with the FAA on type certification. Check out Chris Anderson's presentation in the program. We're working with EASA, we're working with ASD Stand, we're working with ASTM, very deeply involved, and typically that works through individual companies that are core PX4 contributors who are present in these standardization bodies. Is it accepted that automotive standards are accepted by EU regulators? Yes, absolutely. We also expect the FAA to be totally happy with that. In fact, you can prove that the automotive safety and integrity levels can be mapped to DO 178 levels. You can Google for ASIL DO 178 mapping, and you can find documents that people actually have done it before. So we're not just speculating. This is based on other people successfully doing it. Good. Thank you for watching, and please enjoy the rest of the summit. And then I'm looking forward to more great talks and meeting you in person, hopefully already next year.